Hey, how's it going? And welcome back to building a human segmentation model in Tensorflow. Today we're going to go through kind of the final step of building up the model. We're going to go ahead and visualize our model predictions and take a look and do some post analysis, some error analysis to help us kind of figure out and decide where we could take the project from here. So let's go ahead and dive right into it. So go ahead and import our libraries, and then here we already have some of the functions already defined that we've used in the previous notebooks when we were training up the actual model. So the only thing we're going to need to do here is we're going to actually change our pre-processing function. So previously we needed to pre-process these files so that they could be turned into tensors for to be used in our TensorFlow model. Today, the only thing we need to do is actually turn these files into actual just NumPy arrays, so we can kind of streamline a bit of our pre-processing. So we're going to redefine that function. So I'm going to go ahead and call our read image. Going to go ahead and call a read mask. So we're going to need our JSON data and then our shape. Okay, so we're going to go ahead and also do the same thing for our mask. So here basically all we're doing is we're reading in our image and our masks, and then we're going to resize them to the size the model expects. And then we're also going to save their input shape so that we can revert the input images and masks back to their original input shape after we've run our model predictions on them. So go ahead and do that. And then also we're going to go ahead and run np.expand dimensions on the mask because we need to ensure that this has a different dimension for building up for running it into our other processing functions. So there we have it. We have our new pre-processing function. We'd return our image and our mask, and then we also have our shape. Also, so one thing I forgot to mention at the beginning of this, so what you're going to do is in order to actually visualize and use the model that you've trained, is what you're going to do is you're going to go create a new notebook, and then you come over to add data, and then you go click on add data, you go to your notebooks, and then you can go ahead and you can find the notebooks that you have trained, the notebook that you trained your model in, and then you go ahead and click add that output to your notebook, and then you should be able to access your model files. So if you come over here and take a look, I now have access to my model files because I've added the outputs from that notebook to this notebook. Okay, so we have our new pre-processing function defined. The next thing we're going to go ahead and take a look at is it's going to be exactly the same as before. We have our root path for our data set because, again, we have that data set in our input folder for our notebook. And then we're going to go ahead and create those paths just like we did before, and then create the training images and the validation images, and then also for the masks. We're going to go ahead and pass the same config file as we did in order to train the model. And then now the only difference we're going to do is we're going to go ahead and call this function, which I will actually just delete that to show you. So we're going to do is model equals tf.keras.models.loadModel. And then all you have to do is you have to come over here, copy your modeled file path, find it in your input folder, and then just paste it. paste it there, and then you go ahead and click run. Oh, we got to go ahead and forgot to load in our libraries. Go ahead and run that. And then the thing you'll have to pass at the end too also is compile equals false. We don't need to compile it because we're not going to continue our training of the model. And then once you have your model loaded in, what you can do is you can create, basically what I'm doing here is I'm creating a random index in the length of my validation images using NumPy. And then calling image, mask, shape. I'm creating those three variables by calling my preprocessing function on the validation images and validation mask of the randomly generated index. And I'm also passing the config file. And then what I'm doing is I'm creating my prediction where I'm calling my model on the image after I've expanded the dimensions. So basically the image comes in a shape of 128 by 128 by 3. And what you want to do is you want to expand the dimensions so that it is like this, because the TensorFlow model was trained on batches. So this 1 in the 4th dimension is then the batch size. So in order to pass the image to it, we have to make it basically a batch of 1, right? We have to adjust the shape so that that works properly. Once you've done that, you go ahead and resize them so that they're the proper, resize them back to the input shape. So we had to take the input shape, condense them down to make sure that they're proper size for the model. And then once the model's done making the prediction, then we can expand them back out to their original input size. And then we're going to go ahead and call matplotlib to plot them. So the first one's going to be the input image. The second one's going to be the mask, and then the third one's going to be the model prediction. So we go ahead and run that. NumPy array object is not callable. Okay, so something's not quite right here. Give me a second. I'm going to go ahead and take a look and get that fixed. Okay, so I was able to find the error. So in my preprocessing function, I forgot to put commas after image and mask here. So we have to separate the object that's being passed from the shape that we want to change it to. So go ahead and make that change. Go ahead and run the code. And there you have it. So it's kind of interesting to take a look at some of these model outputs. So kind of the general consensus here is you'll see that once you walk through these validation images that the model does a pretty good job of getting the general idea of where the human is versus where it's not, but it has some per pixel inaccuracies. It tends to miss out on some of the finer details of the objects. So what that kind of tells me is, well, first of all, if you take a look at the data set, it's pretty small. It's actually really, really small. So there's only like 500 some images. So in order to train a model on such a small data set, it just doesn't have enough examples to really learn super robust features. Another thing is that we used a Jacquard IOU score style loss, which is very much a pooling type loss, where if you picture a vacuum seal, right, as you're starting to pull the air out of as your vacuum out of the bag as you're vacuum sealing something, the plastic tends to pool around the object. So that's kind of really how these types of losses work, is where they'll first get the general idea, and then as training continues on, and you need to so as training continues on, obviously the loss function needs to continue to decrease because of the nature of gradient descent. So what that does is it makes it harder and harder, so it has to learn more robust features as it goes, which then fills in kind of the finer details. So some suggestions to improve upon this would be to, 1, increase the training data set size, 2, increase the training size. And then 3, if you take a look at this particular example, there's 2 people here, and the one on the left is the only one that's actually annotated in the mask. Obviously, the model picks up that, hey, there's actually possibly 2 entities here. But the third would be to, go through the data set and fix these inaccuracies, things like this, right? So it's just kind of interesting. This is kind of a good way to do some sort of qualitative analysis. So we do our quantitative analysis by watching our different metric scores, but it's important to also do a qualitative analysis to kind of get an understanding and idea of, what's going on inside the data, taking a look at the differences and the different errors that we're seeing, and with that, in conjunction with your understanding of the different metrics and the different loss functions you're using and the model you're using, if you piece it all together, you're able to then kind of come up with decisions in order to improve the system and improve the model and come up with ideas on how to make a better classifier. So I hope you enjoyed. This is really kind of built up in order to just show you, not necessarily to build the best system in the world, but just to show you and give you a decent understanding of a simple workflow in order to get some sort of model going with some sort of data set in a Kaggle notebook. So again, I hope you enjoyed. I hope you found something useful in it, and I'll see you next time.